Everyone, and Ernie, I have no idea what we were listening to. That was Dire Straits, I assume, still, but you know the cut. On every street. So if we look at that, on every street there should be something to do with mathematics. It's a street sign, okay, an address. Make mathematics out of it one way or the other. And speaking of mathematics, we have a test tomorrow. So just a reminder, and so this is confirmation for you and for Palomar and anybody else who wants to know. We have an exam tomorrow. I spent considerable time this morning from about 4:30 on writing problems. So I've written it at this point, and I did precisely what I expect you to do in trying to go back and reference problems. I looked at each section, and I tried to do what we were talking about, and that was looking at a problem section and asking what's a typical problem. Okay? And I actually started with chapter 5, and at the end I went back to 4, 5 because those were the word problems. So I wanted those at the end of the test. So other than that, it's very linear. It starts in 5, goes through 6, then goes to 7, then back to the word problems in chapter 4. And one of the things I have to do while we're talking, since I didn't manage to remember it yesterday, is to go back and on the computer, while we're doing this, I'm going to do a little bit of multitasking. And we're going to do some review this morning. But what I'm trying to do is make it so that we have these dates for some of the homework that has been online available to you. And one of the things I'm going to ask now, we are at, let's see, 4/8 today. You want it to go how far on availability, Shamra? Natalie, how far do you want those? To how long do you want it open? 2 days. So if we're here on Wednesday, I'll just go to the 10th on Friday. That be okay? Okay, and so that's what I'll be doing, and let's make sure that that's happening here. But I'm opening up. Started this with then what I've done just now, and I'll, as I say, be doing this off and on during the hour. But I have this set up so that if you are looking at 7-2, let's see, I have it open until the hold it, 4:10. Okay, so that's starting in 7-2, and you want me to go through 7-5. Is that correct? Okay, we'll do that. Now, in terms of questions and answers, we wanted to do 2 things today. One is go ahead and look at 8.2 and 8.3 and determine if there are any questions in that. And we opened the door on 8.4 yesterday as a way of doing those problems with proportions. Do you have questions on 8.2 or 8.3 that you want to ask about today? Or are we feeling very good about those sections? Okay, so that's not a concern to you. Okay. Yes or not? No, Kim. I'm happy to answer a question. You're getting flustered and you don't need to. We'll wait for Kim to get a problem that she'd like to talk about. While she's doing that, I'll open up another set of problems so that that's available. Okay, Kim, do you have your problem?
Well, the 8.2 is the translation equation and then solve. We're doing the 40 over the 100. Times in the 40 with the 100.
So you have a 40%,
yeah.
And then what's the rest of the problem? Talk on.
40% of 490 is what number?
Okay, so 40% of, and is it what number?
490.
Of 490 is what number? Now, if you just saw this without any other direction, what choices do you have as ways of approaching it?
I would say 40 equals 490.
Well, remember the of gets replaced by what?
Time.
A time symbol.
Times here.
Okay, so you're going to convert the 40% to a 0.40. And since it's an of, and we don't want to use x for multiplication, I'll go ahead and use parentheses, and so I have a 0.40 times 490. The, well, is equal sign, so this is a translation equals x. That would be one approach. Now, if you're asked to do it as proportions, different way. As a proportion, 40 over 100 is, and whether you want to say part or x, you might want to stay with the p over 490. That is as a proportion. Now, when you cross multiply and solve for the letter p, you in essence are getting this. Then I expect this if you, yes. Well, if you are going to do it as a proportion, and that would be my request, given this problem, do it as a proportion, I would expect this. Then as an intermediate step, I would expect to see 100 times p is equal to 40 times 490. And since you want the letter p by itself, you're simply going to divide both sides by 100. Usually consider that over 1. But note, that is exactly what I'm getting here because 40 over 100 is 0.40. It's just another approach. Now the argument, and Sarah and I had an interesting discussion last night on this because we were talking about what should you expect. She sees these two as being close enough, sorry, that you don't have to sit there and say, I'll do one over the other. Now the thing I shared with you yesterday, thinking proportions as proportional thought, as an intellectual process, I think is a very important aspect of analytic thinking. So I like the idea of setting things up as a proportion, as a kind of exercise, so that when you do things with proportions, you're comfortable. This does not in any way provide you this sense of what a proportion is. And cross multiplication, of course, is a way of getting out of the proportion into, in essence, an equation. But I see those as very, very different processes. So I'm tending to emphasize that where I think she is not emphasizing and probably doing the two sections simultaneously. Michael. Okay, Michael's asking, if you have a comfort level up here, which is what I expect, and there's a bit of discomfort down here, should you force yourself to do this? Yes. Now, be careful. Let's go back to that 20-80 rule. If of all the things we're talking about, this idea of a proportion really is a negative influence on you, you stress out with it, then this is where I'd let it go. Concentrate on everything else, and if you get to a test problem and you see that and say, oh God, another proportion, opt out of it and say, well, I'm going to do it this way and hope I get partial credit. So don't belabor it. But as far as homework and trying to get a better sense, I would encourage you to practice proportions. It is what is influencing this level of thinking. And just another comment here, because we're talking about a sequence of courses. We're talking about 70, 90, 100 level courses to open up doors. If you go ahead and you look at what the demands are going to be, there is a kind of change in thinking. Now, it certainly happens between 10 and 20. It becomes a little more abstract, right? You use symbols more. And we expect more in terms of word problems. And if you think of what happens between 70 and 90, it's another little jump of what takes place as you try to think at a higher level. And students do hit walls, where they just fundamentally don't feel comfortable with the processes that are demanded. And so every step we can, trying to open that door wider, to me is an advantage. And that's why I see this as a bit of an advantage here. Marisol, you had a question. Okay, on the test tomorrow, you don't have these problems, because we only go up through 7, right? Now, for the final, I would expect you to translate from the word statement, the verbal statement, to an equation or a proportion as demanded. Now, if I don't give you a specific approach to take, then you have the choice of how you want to do it. Given how much is in Chapter 8, that's in some ways repetitive. If you think of the first 4 sections, it's pretty hard to separate them out. I will be specific. Do this problem with a proportion. Do this problem with an equation. Do this problem your choice. Because I, again, would like to have a problem from each of the sections that I'm covering. So I will make that as a prerequisite to your solution. Other questions on this particular problem? Natalie? Okay, as far as working it out, I would be inclined, well, but again, coming back to Natalie's question, I would be inclined to go ahead and just treat this as 0.4. And then I would take 490 and multiply it by a 0.4. Because that gives me a single digit that I'm multiplying by, and I want one digit after the decimal point. So I'll have a 0.3619 with one digit after the decimal point, so I'll have 196. So you're in agreement with the answer? Okay? Now, in terms of my grading, let's say you set this up. You have the proportion, and let's say it's a 5-point problem, and you screw up this answer. I'll give you 3 out of the 5. Okay? So I would give partial credit. If you get the proportion right, and you mess this part up, you get 3 out of 5. Okay? Any other questions on those problems? Still a question or not?
Well, I just know, because my first calculator was 1960, and I continued to count when I did, but the only thing I forgot was the decimal.
And the decimal would be important, obviously.
You did get so close to proportionally to it, lost the method of a business until 1949, and then multiplied it across the decimal.
Okay, question is being asked because I'm assuming the microphones may not be picking that up. What is being asked, if you cross-cancel here, and you take 10 into here, 10 into here, and then you take 10 into here, and 10 into here again, so you have 4 times 49. You end up with no decimal. You just have 4 times 49, and if you take the 4 times 49, you immediately get to it with no decimal point involved. So that's another approach. That's fine. You have certainly an option as long as it's legal. This is where I would not be willing to tolerate just putting a calculator at your side and say, okay, get me the number with the calculator. Okay? Anybody else in this one? And again, please understand, this is not on the test tomorrow. So this is not time for panic, that if this is still bothering you, we have more time to panic later. Okay, now, the test. There are going to be 20 problems. We're going to play 20 questions. And on the test, it's going to start with 4.5, and it's going to go to 7.5. Okay, and I have, in most cases, about 1 question per section. Now, I think there was one place where I took 2 questions for a section, but then I looked later on, it was like a problem from another section. So they have a tendency to overlap a little bit. And then I tried to keep in mind what I'd done in the quizzes. And so you'll find a couple of the problems very similar to what I did in the quiz problems. So as you study, 2 ways of approaching this. 1, open the book, look at the problems, stay away from the first 20 typically, because they're arithmetic, and then go to the last part, and I tried to avoid going to the very end of the problems and taking the hardest one there. So I went back and said, okay, where does it become clearly a pre-algebra problem? And then I selected one of them that I thought was reasonable doing what I wanted to do. So with that in mind, what is your pleasure of how to pursue this from 4.5 to 7.5? Do you want to just ask questions from a particular section? And if so, where do we start? Okay, Kim.
My first question is 5.8.
Okay, so 5.8 as I come back center. And we'll try to get to a page number here, 5.8. Okay, I'm getting close to it. I've hit 5758. And so I am in the area of 383, 384,
23.
386, 387. So 386 is that where I am? And you're talking about problem 23?
Yes.
On page 386. I'd say you made a good choice for the type of problem that you should be selecting. Now, I'm not saying it is the problem I selected, but a very representative problem. Well, hold on. Give me a moment now before you jump into your question. I'd like to let people who aren't in this class get an opportunity to see what we're talking about. So this is the problem Kim selected. That's an excellent choice. 23. And you're supposed to solve it. Now, do you have a specific question on that problem, or do you want me to do it? What's the process?
I just wanted to know if I did it right.
Well, let's start it out and see what we should do, and then you can make the judgment if indeed you did it correctly. So I'm on page, we said is it 386?
Yeah.
So anybody who has the book, looking at that, looking at number 23, could sit there and see the problem I'm going to write out. And it's going to be 1/2 times x minus 6 equals 1/4 x minus 2/5. Now, there are clearly different ways I can do the problem. So what was your choice for how you wanted to approach it?
Because it says use the LCD.
Okay, so if we're going to use an LCD, you needed a common denominator of 2, 4, and 5, and that would have been a 20. 20 is the only thing that's going to work. It's like an LCM. So if I said find the LCM of 2, 4, and 5, and you counted by 5s, you counted by 4s, and you counted by 2s, the smallest number in all those lists will be a 20. So you then think of taking this in brackets, if you will, and putting a 20 out here. And then in the same way here, put in brackets, and put a 20 out here, and then I'm going to multiply through using what property? Ernie, can you tweak that just enough to see the 20 here, please? I'm going to use the distributive property, correct? And so when you visualize that, I hope you visualize something like fireworks.
I already know that as well.
Yeah, well, it was with your LCD. But finishing it up, I'd still want to do this, and that's my point. Now, here's where you have to be very careful. Because in these two sides, different things happen. Here, I can use the associative property. And I can say I have 20 times 1/2 I'm going to do first, and then I'm going to multiply that times x minus 6. So when you do that, the whole idea is that this 2 cancels here, giving this as a 10. And then I multiply the 10 times the x and the 10 times the 6, getting 10x minus 60. But notice, once the 2 canceled with the 20, I was done with it. Here, if I try canceling this 4 with the 20, you can't do it. I have to multiply through both parts. So this is, in essence, on the right side, 20x over 4 minus 2 over 5 times 20. And there's a very big difference between what I did in the left side and what I did in the right side. Now, this clearly cancels, correct?
Yeah.
But I like showing this step nonetheless. This becomes a 5x. Here, again, we have canceling. That's the whole idea of this. You have no denominators left. This becomes a 4. So this whole equation simplifies to 10x minus 60 equals 5x minus 8. Now, I have, at this point, eliminated the denominator, and that's why the LCD was critical. Before I go on, Jessica. Multiply the 20 times what now? I could have said 2 times 20 is 40, and 40 over 5 is 8. I could have done that. But you can also cancel. Your choice, right? What's the downside of taking the product first? you get larger numbers than you need. But it's not wrong. So your choice. Now, what am I going to do up here? Get like terms on the same side. That is, the x's on the left, the constants on the right. So this is going to become 5x is equal to what? Add 60 to both sides. 52? It always bothers me when we get to a point like that and we go, boop. Okay? That's, at that point, this is not the hard part. And that's where you tend to get what? Glitched. I'm not sure that's a phrase that's in the English language, but you got glitched. That's not nice. I would have loved to have had a 55 here. Or a 45 there. Yes. If we are, the question was, can I end with a fraction? If we started with fractions, a fraction is most likely at the end if you're in a fraction chapter. But I still like getting a 55 better. So you divide both sides by 5, and you don't have to show the 5x over 5 and the 52 over 5, but you can. And so that's 52 over 5, and that's okay. Or you could argue that that's 10 2/5 as a mixed number. Now, would it be appropriate, given that we're working in a chapter just with fractions, to say 10.4? Well, it is, in a sense, a correct answer, but if you're wanting to have things with fractions, then not appropriate if we're trying to restrict ourselves to that. And that's the game we played. If you're in the fraction chapter, you should get fractions. If you're in the decimal chapter, you get decimals. And, of course, that's part of the problem in the computer. Occasionally, things went a little bit inconsistent with that. Michael. The question that's being asked again, is it appropriate to go here rather than just leaving it here? I would not have a choice there. Since I didn't start with mixed numbers, I'd be very content with the improper fraction. But a caution there. I want you to understand that even though, from my perspective, and I think many mathematicians teaching a course in algebra, pre-algebra, they'd say, this is good, go with it. In the world where you have to share your answers sometimes with somebody else, they will prefer this. And so certainly if you take a test, an assessment test or something, whether it's for a job or for another course, and it turns out that in that assessment test they gave you either this one or this one as your choice, multiple choice, you need to understand that most people will consider this the preferred one, and so don't, out of pure unmitigated stubbornness, say, I'm going to stay with that, even though this would be what most people would want. Okay? Does that answer the question for that particular problem?
I was working, I was going with the 1/2, I was changing the x minus x. I was doing that part, then finding the other.
So you actually multiplied 1/2 times x and the 1/2 times 6, which gave you a 3.
And so my LCD was 60. Because I had 12. And then I was...
Okay, wait. Where did you get the 12?
Because I multiplied...
1/2 times x is x over 2.
is 1 over...
And this becomes a minus 3.
Wait, no, I was going 6 over 12. I was times
You mean 6 over 2?
because that's times 2. That's how...
Yeah, okay, but if you had 6 over 2, you don't have to reduce it, but you still have...
Oh, but I was making it 12.
I don't have an idea in the world. So if you had a 12, what you did for your LCD makes sense, but I don't see where your 12 would come from, and I think what you were doing, in your head saying 6 times 2 is 12. And then it just throws everything off. Jessica.
So are we able to do the 1/2 of the...
If you want to use the distributive property out of the gate
Yeah.
and get 1/2 x minus 3 and then multiply through by your LCD, you may most certainly do that.
Okay, I was making sure.
You'll get the same answer.
That's why
So you have a choice.
you were doing that, I was like, maybe I'm doing it
No,
wrong.
you can apply the distributive property, then multiply through, and you'll get exactly the same answer. So again, do what your comfort level dictates. Now, by the way, if your comfort level is, I'm not going to do that problem, that's probably not wise. Okay, Richie. Okay, LCD. In a sense, if I'm looking at 2 and at 4 and at 5, and I just look at those numbers, they're denominators, so we can think of them as hunting for a common denominator. But a common denominator is a common multiple. So I could just say, find me the common multiple of these. And we had two methods we used before. We counted by 2s, 2, 4, 6, 8, and so on. We counted by 4s and got 8, 12, 16. We counted by 5s, got 10, 15, 20, and so on. And we keep these lists going down until we find the same number in each list, which is going to turn out to be a 20. If you don't want it that way, we talked about prime factoring. And we didn't do that very much as we looked at these problems because we'd done it in 10. But you look at the denominators, so I have a 2 is 2 to the first. A 4 is 2 to the second. A 5 is 5 to the first. Those are my denominators in prime factored form. Then when we found common denominators, the least common denominator, we said write the primes you see and then take the highest exponent. And so that was a 2 and that was a 1. Those were the highest exponents, and that gave you 4 times 5, which was 20. These numbers are small enough, it probably doesn't make as much sense to you, and let me give you a different problem. Let's say I had 5 over 12, and I wanted to add 7 over 18. The process we did here, because it's a little more complicated, this was 2 to the second, 3 to the first, and this was 2 to the first, 3 to the second, and you could do that by dividing, where we divided 2 into 12, we got a 6, 2 into the 6, and so on. So we actually went through this process. Just to refresh some memories, because this is one of the things that gets lost so easily. And then I did the 18. And I did the 2 into the 18, I got the 9, I did 3 into 9, 3 into 3. We stopped when we got to the 1. And then I said, this is 2 to the second, 3 to the first. So that's where this came from. This was 2 to the first, 3 to the second. And then your LCD is always take your prime divisors that you use. We use 2s and 3s. Then take the highest exponent on the 2. 2 to the second, 2 to the first, so I had 2 to the second. I had 3 to the first, 3 to the second. Take your highest exponent, which is 2. That becomes 9 times 4, or 4 times 9, which is 36, and that's what we did for the LCD in problems in Math 10. Now, you're certainly allowed to go through that process. If we think in terms of the denominators I had, you didn't have to do division like this particularly, but it's the same concept. I would have divided by 2s and 5s. Highest exponent in the 2 was a 2. Highest exponent in the 5 was a 1. 2 squared was a 4, times 5 is your 20. Same concept. And of all the things we've done with equations, I'd say this ranks up there as one of the more difficult. Finding the LCDs. So, I showed you in terms of problems along the way that are like 70 and cause trouble there. If I were to give this problem, we had actually over here, let's slide over now, Ernie. If I gave this problem without all the mess now, I just gave the problem the way Kim asked it, and I gave that in a 70 class, they would have trouble on a test. And my guess is it would be one of the problems missed most often. Okay, the reason for it has to do, 1, with the LCD. 2, they will be inclined not to do what Jessica was talking about, multiplying the 1/2 times each of these. They'll put the 20 out here in front. They'll do the left side okay. They'll divide the 2 into the 20 and get 10. The error they will make, they will cross this 4 out, put a 5 here, and then multiply 5 times this and 5 times this, rather than multiplying the 20 times each. And they'll make a mistake. And it's over half the students typically would make a mistake in that problem. So if you look at it as a problem students are going to make a mistake in 70, then in a pre-algebra, you'd have to rank this up in one of the more difficult problems we've looked at. Now, again, put things in perspective. You look at this problem and you go, oh no, I know I'm going to bomb this problem. It's 1 out of 20. Do good on the other ones. And then you can afford to lose a problem here or there. Kim was next.
I have a question.
And Richie.
On the same problem here.
Okay.
Where do you have the 20x? You multiply the 20 and the 1 and get the 20x, right? Am I correct?
Yes, the 20, I wanted to demonstrate that I was multiplying the 20 times this before I reduced. And then the 20 times this before I reduced.
You would times the 20 and the 4 also, wouldn't you?
No, I would not.
The 4 stays the same?
If I had, okay, let's come back to that. This is just a question, I'll put it up here. If I ask you for 20 over 1 times 1 over 4, I think that's what I had, what would you do? If you don't want to cross cancel, wouldn't you get 20 over 4? Does that answer the question? Okay, so this becomes 20 over 4, which is what I was trying to get at over here, where I had, thank you, a x over 4 instead of 1 over 4. But you just multiplied 20. This is a 20 over 1, and if that'll help you, avoid that error. See, you aren't changing a fraction, and I think what Kim's getting to as we slide back over here, if I had 1 over 4, and I wanted to make it as something over 80, then I'd multiply the 20 times 4, and I'd have to multiply the 20 times the top number. Because I'm trying to change a fraction to something that's equal. When I, sliding back over, am applying the distributive property, I'm just multiplying 20 over 1 times 1 over 4, which gives you 20 over 4.
So would you multiply the 20 and the 2?
I did. And that's where I think it was Jessica who said, well, can you do that and get 40? Yeah.
Oh, okay.
And 40 over 5 is 8. Or you can cancel and get 4 and the 2. Okay, but what I'm getting at here, and this is instructive for me and for you, we've spent 8 minutes in this problem. We have 20 problems. Okay, and we spent 8 on this. It's an unreasonable amount of time on a problem which I may or may not give something that complicated. And if it's giving you that much trouble, I file this into problems to look at later, but I'm going to spend most of my time on all the stuff that I know how to do and then do it. That last part. And do it. Don't just look at it. Do the problems. I call it pencil pushing. Do problems. Carry them through. Okay? Other questions, because we need to let this one go. And by the way, in a test, know when to let go. Richie.
So you only distribute the right side, right?
Okay, the way I did it, I distributed the right side because I took care of this getting in that first step a 10. But then I did distribute the 10 coming across. You don't see it, but the 10 here and the x minus 6 there. Notice this 10 here, the x minus 6 became 10x minus 60. So I did ultimately distribute. Now, if that distinction bothers you, go back to Jessica's. Multiply these out, and then find your LCD. But you are using the distributive property in both parts. Here I had an intermediate step. I saw a hand up. Whose was it? You were just brushing your head. Okay. Another problem. Good. Okay, another different section problem. What is your problem? 5.3. Okay, we're still in chapter 5, so I'm going to back up now to 5.3. Well, hold on. I need to get there first. We're on page 328. 329. Number 65. Okay, so we have exponents galore. Okay, so Ernie, I'm going to leave that on the document cam and have you come over to the sideboard. And note, what number is this? 65. How many problems were in this set before we went to the word problems? 66. So you could argue that this has a lower ranking of importance than, say, a 50 problem. But we'll stay with it. 65, and your page number again was? What page? 329. Isn't that neat? 329? That's 3 squared is 9. Okay, so we have a minus sign, and I'll write the problem. That's cubed. In, I'm going to put a 1 there, even though it's not written, a 3p to the second, and then I have a 4 out here. Now, there are two ways of doing this problem.
I know how to do this problem. The only thing I get confused on is because you remember when we had problems before, it was the negative, you would like negative, positive, negative, positive. So I thought the whole problem, because it was a negative, it would become a positive.
Okay, I heard a lot of things stated, and I suspect you weren't able to pick that up in the mic, although I understand now, Ernie, all the mics are working on this new board we put in the last hour. So we could possibly pick up some of that if we work at it. Now, since I have 4 negative factors, my answer will be positive to answer your question. It has to be, if you have 4 negative factors, it must be a positive answer. Okay, make sure you're looking at the right problem in the right page in the answer section, because I've spent an hour on a problem when I was looking at the wrong answer. Shamra.
That negative sign is in the middle. It's not.
That negative sign, as, let's go back to the problem, that is inside the parentheses. That means, in essence, coming back to the board, I have minus m to the third, n to the first, over 3p to the second, times minus m to the third, n to the first, over 3p to the second, times minus m to the third, n to the first, 3p to the second. And if you don't look at this and go, my gosh, there's no way I'm going to do that, then I have not sufficiently intimidated you with this potential solution.
Okay, it was positive.
Thank you.
Sorry.
It was positive. Now, do you want to go through this, although that's what's intended?
No, I got the right answer.
Yeah, but you opened the door.
Oh, okay.
So the question, is there a better way? Yes, there is. And that was knowing that x to the m to the n is x to the m n. So if I do that, and understanding that I'm going to have a positive at the end, I'd say I have m to the third to the fourth, n to the first to the fourth, 3 to the fourth, and p to the second to the fourth. That would be my intermediate step. Do you follow that intermediate step? Okay. Well, the question is what intermediate step and how you approach it. Before I go any further, Michael.
Sign next to the 3 and then put the 4 next, like on the
So
top
you
part.
want to have this, m to the 3 times 4, n to the 1 times 4, over 3 to the 4th, p to the 2 times 4. Am I hearing you correctly? That is acceptable. But either approach, you're going to end up with m to the 12th, n to the 4th, over 81, sliding just a little bit if you would, Ernie, 81 p to the 8th. Done. Natalie? Is that the answer you got? Okay. Whoa, 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 whoa. A 4 in front of the m? Uh-uh. I don't see where you get a 4 in front of the m. These were not added. These were multiplied. Sandra?
The only way you do that is if it had a coefficient, right?
Well, I did have a coefficient. It was hidden in the denominator. I had that 3 to the first to the fourth, that became the 81. Technically, that's a coefficient. I could say 1 over 81 times, this can be rewritten this way, and it does give me a coefficient. Now, in your question, it suggested that you're seeing a coefficient as a whole number. Here's a coefficient that technically is a fraction in which you're multiplying it times this particular monomial, rational monomial, in which 1 over 81 is the coefficient. These two are the same. Okay, and this is coming back to a basic argument that tends to cause people trouble, that 1/4 times x over 1 can be rewritten as x over 4. And that's one of those things that just simple, but it messes you up. And it gets back to what we had in that front board, Ernie, in the far right front, where I had 20 over 1 times 1/4 up in that right upper corner. And if we look at that, that's exactly what we're talking about there. So as we bring that onto camera, these two ideas are simultaneously done, the product of the numerator over the product of the denominator. Coming back to the sideboard, the product of the numerator was x, the product of the denominators was 4. Marisol. So I think, as Ernie, as we slide over, we're contrasting in Marisol's question, which of these two I would accept either. But I would like to see one of the two. I wouldn't want to see you go from here all the way down to the solution. I'd like to see an intermediate step. And if you feel obsessive about doing it this way, I'm not going to take points off, but you'll have my sympathy. Okay? Other questions? Kim? 5.5. Let's go back to the document, Cam, if we could, Ernie. 5.5. And what page number are you on? 351 as we come off there, Ernie, to me. I should have let you know what I was doing. I know. I had you over there. I should have telegraphed that. 3 what now? 330? 351. Ernie and I were having a communication problem about where I was going to be. And which problem is it? 49. Hold on. Just let me get there before we talk. Okay, let's go to the problem, Ernie. Now, this problem, notice, and here's a comment as we come off there for a moment, Ernie. Make sure that as you look at each of these problems, you look at the direction that went with them, so that you recognize what should be expected by the direction provided. Because in the test, that will be a place where you're going to be having trouble. I tell you to do something, you've got to remember how to do it. Going back to Richie's question of finding the LCD, if you don't remember how to find the LCD and I ask you to do that, the rest is going to be bad. So the direction here is stated as write the equivalent fraction with the LCD. So the argument here is, as we come back to this problem now, find the LCD for 18x squared y and 12xy cubed. So what I'm going to write for a moment, and I'm going to come back to Richie's question, I want the LCD, give me a moment, Ernie, before we change, of an 18x squared y and a 12xy cubed. Now as we go to the board, I have to have this first. So a reminder that if you don't see the exponents of a 1, write them in. And now I know at the end I'm going to have an x to the second, y to the third. Because these parts, the right parts, are already in prime factored form. Now I need to know something about 18. 2 to the first, 3 to the second. And the 12 is 2 to the second, 3 to the first. So using the idea we just talked about, and this is exactly fortuitously, boy, talk about rigging your hour. Ernie, where you were in the right board before we went back to center, going back to where we were, do you see the 5/12ths and the 7/18ths? Do you see that? Will you bring that on camera, please? As I say, it's nice when the world works the way you want. Because I used this as an illustration, not anticipating the question that was just asked. But I talked about having a 12 and an 18. And what did we say you did? You wrote them in prime factored form, correct? And so your LCD was going to be that 2 to the second, 3 to the second, which gave us the 36. So as I go back to the sideboard now, Ernie, and I look at the 2 to the first, 3 to the second, 2 to the second, 3 to the first, I know the LCD out of this is just going to be that same 2 to the second, 3 to the second, and most of the time you'd be inclined to write that as 36x squared y cubed. Now back to the document cam. That's part one of this problem. Part two of the problem is to take, and I'll just take that z part for the moment, where I had z, I think I better do it down here, z over 18 x squared y. And so what's being asked here? And I'll demonstrate on the board in just a moment. Okay, now we can do it. If you look at what I had, and this is what I want, this is that good old problem in Math 10, change a fraction so it's a new fraction with a new denominator. And you played this game by saying 18x squared y will go into this. You divide, or you can say, what am I missing here? I have x squared, y to the first, and I wanted a y cubed. So I have to multiply here by a y squared. And Kim, this is now where I multiply top and bottom by the same thing. Basic principle of fractions. I had an 18, I want 36. So I'm going to have to multiply by 2. Top and bottom, numerator and denominator, the top being the numerator. Now, this product will give me the new LCD. So I have 2y squared z, and I've changed that fraction. I do the same thing for the other one. And whether you write a 1 here on the z, your choice. But that's it.
So that's going to be 2
Y squared z. That's it. For that part. Now I have to do what? If I come back to the document cam, I have to do the same thing for the minus 5, and I hope you see there that I'm going to have to multiply by 3x. Okay? So, to that extent, I don't want to do much more in this problem if I can avoid it, because we can do something else then. But that, by the way, for the most part, what you're choosing and what you're asking are very well-chosen problems and good preparation for the test. If anything, you may be going just ever so little more difficult than I might choose. But this is one that's very close to what I would choose. And I was asking the same questions this morning as I was drinking coffee, looking at the problems and writing them down and trying to make those judgments. And as I said yesterday, I think you can make very valid judgments. You'll be within 1 or 2 problems of where I am. Not the same problem statement because I adjusted them, but you'll be picking the same kind of problems. This one was a good case in point. As I said, the one at the far left that we did, that to me is a little harder problem. Okay, so I wasn't as concerned about that as this one. Any other questions? We have a few more sections than you've asked about. Michael? Okay, let's go back to the document cam, Ernie, and then I will go back center following that. So back to the document cam and then center the camera for me so that I can be on camera when I make the change. Okay, back to center. And then what page number are you on?
281.
281. So we back up a bit. 281. Oh, my goodness. Okay, 281. And which problem is it?
Problem
22? 22 with a suspension bridge. Okay. Makes my engineering days seem fun again. A suspension bridge has a steel beam that connects to the flat surface of the bridge, forming two angles. The measure of the smaller angle is 38 degrees, less than the measure of the other angle. So the two angles in question are where? Right here, agreed? These two right here. So the smaller is 38 less than the other. So if I knew the big one, this one's what? 38 less. How do you translate 38 less, leaving that there? Yes. If x is the big one, and let's see if I can draw on the board just that portion of the bridge. Okay. And I think this is an appropriate problem because we're a bridge class. You don't see any humor in that, I can tell. Okay, this angle here, as we go now to the board, is what we're going to call x, because I don't know that angle. But I know the smaller one is 38 less than that, which translates into x minus 38. But what do I know about those two angles? They create a line, correct? So we argue that that's called a straight angle. These two, in essence, are supplementary to each other, saying that their total must be 180, and that's the piece of information that you needed, because now I can create this equation and say that the sum of those two must be 180 as a straight angle, and then I'm done. Now what I want to see is let x equal the larger angle, and technically I'm going to use that symbol for angle, and it should be the measure of the larger angle. So I should say the measure of larger angle. Sandra,
How do you decide
which one's x and which one isn't?
which ones you let x?
Well,
What you also do is let x equal the measure of the small angle.
okay, but if x is the smaller angle, how are you going to take 38 from it and get the bigger one?
See, that's what I want to know. I want to know how do you determine which one.
If you're going to have a larger and a smaller, and you're going to take 38 from the bigger, then it would make sense to have the bigger one as x. But let's say you said the smaller one's going to be x. Then if the smaller one's x, and I hope I'm not creating more of a problem than I'm helping. If so, blame Sandra. She's sitting right there. Now, let x be the measure of the smaller angle. So the real question here, if by my choice I screw up, I'd like to avoid it. Or does it matter? So let's play the game. If x is the smaller angle, then the bigger one has to be what? X plus 38. So you have x and x plus 38, and it's still going to equal 180. Now let's see what happens as I solve these two equations. This is 2x is equal to what? 38 from 180. Thank you, 142. So x is, divide by 2, 71. Good. So your small angle is 71, and what's your big angle? 38 more. So that's going to be 109? So x plus 38 is 109. So you got 71 and 109. Okay, now, Michael and I did x as the big angle. So here you get 2x is equal to what? 218? And so what's x? I wrote 8, 9, curl. Say what you mean and write what you say. How about 218? Now what is x? If 2x is 218, divide by 2. Come on. 109. And now the other one has to be 38 smaller, so x minus 38 is 71. Do I get the same answers? Yes. Those are my two angles. Did it matter? No. Your choice. Yes, that's why it is, and what Michael said, it all depends what you want x to be. It is very critical, let's bring this up higher. It's very critical you tell me what x is, not just for me. For you. If you don't know what x is, how are you doing the problem? So that first step, you tell me what x is. And if on a word problem, you don't tell me what the variable is, and it's a 5-point problem, you're at least losing 1 point. And if I'm getting really angry that nobody is identifying x, then I'll take 2 points off. And then have to curve the test back up because out of anger I took too many points off. But nonetheless, I will have solved my problem, which was my frustration. Okay? Now, what we have managed to do in about 40 minutes is 1, 2, 3 problems that are on the test out of 20. We must be more efficient than that on the test with 20 problems in 60 minutes. Now, I wrestled with that this morning. And I said, okay, I spent about an hour writing this thing, and I'm expecting you to do it in an hour. But I was spending a lot of time deciding what problems to do, writing them down, checking out to see if it looks like it's going to work out well. You're going to have to work efficiently. So when it comes to the test tomorrow, you have a blue book. And on the blue book, keep an order, but do the problems that make sense to you. Leave maybe a half a page for another problem if you didn't do it and come back to it. So Ernie, I have run out of the time by a bunch, and so we started with dire straits.